So to deal with this data skewness, where the data is like unevenly distributed across the partition, and making sure we do efficient utilization of the worker nodes, we use a technique which is known as salting. Let's understand this technique, which is being used widely to deal with data skewness. So salting is a technique used in Pyspark and distributed computing in general to address the data skew problems during join operations or aggregations. Data skew occurs when one or more keys in your dataset are significantly more common than others, causing uneven distribution of workers across partitions and potentially leads to performance bottlenecks. So when there is data skewness, the worker nodes dealing with this data skewness takes more time to complete a task while other worker nodes are sitting idle. So to make sure like the work is evenly distributed across all those worker nodes, we introduce this concept of salting. Now, why the name salting? Like it's like literal salting, like how salt spreads evenly when sprinkled. This technique helps spread data evenly across partitions. In PySpark, this concept is similar. We are adding salt to the keys to distribute them more evenly. Let's get a very high level highlight of what's happening, and then we can look into the details of the code. So the basic concept of salting is simple. Take the skewed keys and append the numbers, which is a random number. Also, we are calling it as salt to them. This transform one heavy keys into multiple lighter keys. Then we perform operation on these salted keys, and finally we remove the salt to get back to the original keys if needed. So let's look into this in detail. This is the main part. So I would like everyone to bring your attention to here. So what's happening? So if we see the DF1, which is highly skewed on the country column, where like USA has like the most number of records and followed by UK and then India. So we saw earlier that we had two data over DF1 and DF2, and DF1 looks like this and df2 looks like this, country and value 2. Okay, now our main aim is to join df1 with df2 on the country column. So as I was saying, like since this is a very skewed data, so the join will take much more time as compared to when we do a little bit of salting to make sure. So since this is a skewed data, this join is going to take much more time. Why? The work is not evenly distributed across all the nodes or like all the partitions. A few partitions will be having more records as we saw over here. So the worker nodes involved in processing this particular partition will take more time as compared to while the other worker nodes will complete their task quickly and will be sitting idle. So what can we do to make sure like this is evenly distributed? So for that, we are introducing this concept of salting. So as I was saying, our major aim was to join this df1 with df2 on the country column and bring the three columns into one data frame, which is like for a particular country, what is their corresponding value 1 and what is their corresponding value 2. Let's look into this particular salting technique and see how to do this. So in the df1, we have like USA 1000 records, India 50 records, and UK 100 records. So we are introducing this concept of salting, where we are creating a new column known as salted country in the df1, and we are concatenating. Basically, concat this column country, then there is an underscore followed by this particular salt, which is basically saying f dot floor means whenever it's a decimal point, take the lower value. If it's 3.5, take it 3. And rand actually generates a random number between 0 and 1, as you can see in this particular documentation. And we are multiplying that one with a salted range. So the salt range over here is 4. So if we take 4 and a random number between 0 and 1, say like 0.6, so this will give us the value 2. But I just want to point out any random number between 0 and 1, if you pass this as an input over here instead of 0.3, then it will return a value between 0 to 4, where like 4 is exclusive. So basically the values returned will be having the values 0, 1 to 3. That's the mathematical beauty of this particular floor function when multiplied with the salted range into our salt values, which is a random value. Now if you see the distribution of the salted country then we can see it is kind of better distributed. So if you see like USA earlier had 1,000 records, but now USA instead of USA has been further bifurcated into USA 0, USA 1, USA 3, and USA 2. Similarly, UK has been divided into UK 0, UK 1, UK 2, and UK 3. And India also has been divided into India 1, India 0, India 2, and India 3. So that's how like this sorting occurs. And you can see now the data is like more evenly distributed. Earlier USA had like 1,000 records, but now USA is itself divided into 4 different parts, and the counts of the records corresponding to it is better distributed. Now we perform similar kind of operation on the other data frame, because this sorted country will become our primary key while we will be joining it with df2. So for df2 also, like we have to create similar kind of column, salted country. Let's see how this works. First of all, we are creating a salt value, and the salt value is an array, and it has 4 values in it, 0, 1, 2, 3, corresponding to each of the record. So as you can see, the first line is actually corresponding to USA. There is a value A, and it has like 4 values, the salt values 0, 1, 2, 3. Now what we will do is like we will explode this array. So basically from this wide format, it will become long format, which is, I will show you how it is being done. Earlier, corresponding to USA, there was a value A, and corresponding to value A, there was a list of values, which is like salt values, which was 0, 1, 2, 3. Now, from that width format, we have converted into long format, where like the corresponding to USA A will have 0. Again, USA A is repeated 4 times, and we have like this value 1, 2, 3. Similarly for UK, and similarly for India. Finally, we concat this country and salt values to form our final salted key, which is like salted country for the other data frame, which is like df2 data frame. So over here, we are concatenating the country followed by an underscore followed by the salt values, which is like this random number 0, 1, 2, 3. Let's see how this looks like. So we have now the both of the data frame are ready. Data frame 2 has this salted country over here. This is the primary column for data frame 2, df2, and similarly we have the salted country. If I can show this, so here also like we have like this value and salted country. This salted country is a primary key for the df1 or df1 salted, and similarly for df2 also there is a salted country, which is the primary key for data frame 2 or like df2 replicated. Now what we are doing is like we are joining df1 with df2 on the primary key is salted country. I would like to bring it over here again. Earlier the primary key was just country, but now after salting we have the new primary key, which is like salted country, and we are doing an inner join of both of this. And we are selecting few of the all the columns from df1 salted, and from df2 we are just selecting the value 2 column. So yeah, so you can see like we have the country, value 1, salted country, and value 2. Now since this join has been completed, we don't need this salted country column anymore, so we will drop it in the next part. So that's what we are doing over here. And yeah, that gives us the country, the value 1 and the value 2. So that's how the salting works. That's a wrap for today's video. If you found this content valuable, make sure to hit that like button and subscribe to the channel so you don't miss out on future insights into data science, AI, machine learning, and analytics. Looking to master data science or drive data-driven success? I offer expert training, mentorship, and consultancy for individuals and organizations. Let's collaborate. Reach out via my contact details in the bio.